Hi, I'm Michelle Karkinen. I'm a math teacher here at Valencia, and I'm here to give you 2 quick words and then 3 easy steps that's going to get you in shape for your biology problems. So, first quick word, and this should just take a few minutes. The first quick word I need to give you is about scientific notation. The second quick word I need to give you is about exponents, and then we're going to do 3 quick steps, and you're going to be able to do your biology problems. Scientific notation is a convenient way of writing really big numbers or really small numbers. So, the form of scientific notation takes is a number, point, something, something, times 10 to a power. And so we're going to transform each one of these numbers into scientific notation. 527, you take the decimal point from wherever it is, and then you move it so that it's 1 to the right of the number you were given. So 527 would be written as 5.27 times 10 to the something. So now we decide what power goes there. That is dependent on how many times we move the decimal. So it started off here at the end, and we had to move it 2 times. So the number 2 goes here. The last decision we make is, should this be positive or negative? If the given number that it ended up looked like 527, if this is smaller than the original number, 527, which it is, that means this is negative. Let's do that again. We have 3,850. To write it first in scientific notation, we move the decimal from wherever it is to just to the right of the first number. So this is 3.850 times 10. If this number looks smaller than 3,850, and it does, we make our power is going to be negative. We had to move it 1, 2, 3 times, so this is negative 3. One more time, 211 will turn into 2.11 times 10. How many times did we move this guy? Once, twice. So the number 2 is going there. This is smaller than 211, so this turns negative. What if we have this, 0.129? Well, the form is to move the decimal. We have to move it to the right, so it turns into 1.29 times 10. And how many times do we move this decimal? 1 time. But if this number is bigger than 0.129, and it is, this remains positive. One more time, 0.00175 will turn into, we move the decimal to the right of the 1, 1.75 times 10 to the, we move the decimal 1, 2, 3 places, but this is bigger than what it originally was, 0.007, so this is positive. This is the first word I needed to give you about scientific notation, how to put a number in scientific notation. Second quick word on exponents. Exponents, how you combine exponents. If you have a base, which right here we do a 10 to the third, 10 to the 5. If they're being multiplied, you simply add the exponents. So this is equal to 10 to the 3 plus 5, or 10 to the 8. 10 to the 2 times 10 to the negative 3, we're going to add the exponents. 10 to the 2 plus negative 3. 2 plus negative 3 is negative 1. This is equal to 10 to the negative 4 plus negative 5. This is 10 to the negative 9. That's when you multiply. Now, this is really important. When you divide, one simple thing happens. I can transfer the denominator number to the numerator, but when I do that, the sign, positive, negative sign of this will change. So right here, 10 to the third divided by 10 to the fourth is the same thing as 10 to the third times 10 to the negative 4. When I move that upstairs, it gets multiplied on, and it becomes negative. Then I just do what I do here. This is equal to 10 to the 3 plus negative 4, or 10 to the negative 1. That's what happened here. Over here, this is a division problem. 10 to the negative 3 divided by 10 to the negative 5 will become 10 to the negative 3 times 10, I have to change the sign when I change it to multiplication to the positive 5. And these simply get added. Negative 3 plus 5 is 10 to the 2. So those are the 2 quick words, and now we're going to do 3 easy steps. Okay, 3 easy steps. Step 1, we're going to take a number and put it in scientific notation. Step 2, we're going to divide it by another number. Step 3, we're going to make a decision. Is our result greater than or less than this number? I just made this up. But here's the scenario. You've got a biology problem. You're trying to decide if you have to boil your water because there's been a pipe bust. And so you have a sample, different samples. So like maybe we have a sample that has a colony count of 527. And so you need to say, but it's in a certain plate count. So you need to divide by the plate count and see, does this meet the criteria for boil or not boil? And you decide that by saying, is it greater than or less than that number? So I'm just going to do like the math part with you. Let's take these numbers and first put them into scientific notation. So here's the first example, 527. Put it in scientific notation. Well, we just did this a second ago, but we're going to say this is equal to 5.27 times 10 to the, and so since this number's smaller than this number, since the original number was bigger than what we made it look like, this remains positive. 211, this becomes 2.11 times 10, since we moved the decimal twice, and since the original number is bigger than what we made it look like, that stays positive. 30,579, we're going to move the decimal from here to here, which is 4 places, so it becomes 3.0579 times 10. We moved it 4 places. This original number, 30,000, is much bigger than what it made it look like, so it's 10 to the 4th. 3,850. We're going to make this look like 3.850 times 10 to the 3rd. We moved it 3 places. The original number is bigger than what we made it look like, so that's positive. Now let's suppose that these are from different plate counts, and so the plate count that this one's from is 1 times 10 to the negative 3. Let's say that this one is from 1 times 10 to the negative 4, and this one is 1 times 10 to the negative 7, and this one is 1 times 10 to the negative 8. Is that too much? We'll say 5. Okay, so let's just suppose, I'm just making these up, but this is what we'd have to do. We'd have to take this number and divide it by this number. So let's do that. First example. Take 5.27 times 10 to the 2nd, and we're going to divide it by this plate count, 1 times 10 to the negative 3. And sometimes they don't write this one, they just say 10 to the negative 3. It is okay, it means the same thing. Look at this. A number divided by 1 is still that same number, so we don't even have to worry about this. This is really 527 divided by this. And if you remember a second ago, when you move something upstairs, this is 5.27 times 10 to the 2, it becomes positive times 10 to the 3, and then these get added. So this is really 5.27 times 10 to the 5th. We want to compare our result with, is this greater than or less than 10 to the 5th? Well, 10 to the 5th is the same thing as 1 times 10 to the 5th. So since 5.27 is bigger than 1, this is greater than. That's how we would make our third decision. All right, second example, and so maybe I need to make this a bigger number. Let's make this to the 7th for the rest of these examples. That was example 1. Okay, you're done. Let's do example 2. I've got 211 as my sample. I need to divide it by the plate count, which is 1 times 10 to the negative 4th. So first I change it to scientific notation. Then I say 2.11 times 10 to the 2nd divided by 1.1 times 10 to the negative 4. If you're dividing by 1, it doesn't change things, so you can basically ignore this. This becomes 2.11 times 10 to the 2, When you move something upstairs, it changes the sign, so this gets multiplied as 10 to the 4th, and then you can just add these. Is 2.11 times 10 to the 2 plus 4, which is 6. Is this bigger or smaller than 1 times 10 to the 7th? Well, 10 to the 7th is bigger than 10 to the 6th, so this is less than that. That's how you can compare those. All right, that's the second one. 2 more of those. You guys are almost there. Let's do this one. Is this number, our sample, 30,579, and this plate count, is this greater than or less than 10 to the 7th? Well, we've got, in scientific notation, 3.0579 times 10 to the 4th divided by 1 times 10 to the negative 7th. Remember, the 1 doesn't make a difference, so you can just ignore him. Then I can move the 10 to the negative 7 upstairs. And when I do that, that becomes 10 to the positive 7. And after I do that, these powers get combined. That's 3.0579 times 10 to the 4 plus 7, which is 11. Is this bigger or smaller than something 10 to the 1 times 10 to the 7th? Well, 11 is much bigger than 10 to the 7th, so that's bigger. So I guess boil, whatever you'd have to say. All right, let's last one. 3,850 is our sample. Our plate count is 1 times 10 to the negative 5. So we're going to divide this by this and compare. 3.850 times 10 to the 3rd divided by 1 times 10 to the negative 5. 1 goes into this 1 time, so you can ignore the 1. When you cross the fraction bar, when you divide, you can change it to multiplication, but this has become a positive 5. Then these can be added. So this is 3.850 times 10 to the 3 plus 5 is 8. Is this bigger or smaller than 1 times 10 to the 7th? 8 is bigger than 7, so that is bigger. And so I think that's all you need to do your biology problems.